Okay, so I'm recording. Welcome to week 4. It's crazy. Class number 2. We're going to continue our look at the periodic table. It's an interesting chapter because there's no calculations. We're basically just looking at the different parts of the periodic table. We're spending like a week just talking about one thing. That's how amazing the periodic table is. So, the layout of the periodic table, I'm on slide 9 here. I talked about most of this the other day, but this gives a pretty good example of all of the different parts. The ones that you're really expected to know are the first two. They are by far the most common. We call them main group and transition metals, A and B. There are the inner transition metals, which we don't really deal with. And let me go back a couple of slides and show you this periodic table. These are the inner transition metals. And where they actually belong is right here. So if you really drew the periodic table out, you should be actually putting this really big, long block into this space. The only element in the inner transition metals that we care about is uranium. Whoops. But other than that, we don't really care about the inner transition metals. It's not, I mean, I spent 4.5, almost 5 years working at chemistry degree. I never used any of these. They're not common in most chemistry programs. So let's go back and look at this slide. The green are your A block. The blue is your B block. And the easiest way, and again, inner transition metals you don't really need to worry about. So remember what I said to you guys yesterday. Think of the periodic table like a castle, a medieval European castle. I can't get my pen to stop doing that. Okay, there we go. Oh, I went way too big. I'm being a perfectionist now. Okay, and if this was a castle, the towers of the castle are A. The towers, the columns, the spires, the tall objects. And we call A the main group. A lot of the chemicals we use in first year, second year chemistry will be from the main group. B, we call transition metals. Okay, they are much more complicated, and we will use some of those metals, things like iron and nickel and copper for sure. So I did cover that yesterday, so that's really it. The big thing I want to talk to you about today is, and this is basically all I want to talk to you about today, is metals versus non-metals versus metalloids. Now, one thing I want to mention, metalloids you will often hear me call semi-metals. I think that's like a hyphenated word. I don't really care too much about your spelling, don't worry. The only time I'll ever care about your spelling is if you have to spell a chemical name. And even then, as long as it's not too big of a mistake, you'll be fine. So don't worry about spelling, but these are the 3 types of elements based on metallic character, so based on how metallic they are on the periodic table. I'll go through all of this kind of slowly, but the idea is non-metals, that's the green guys, they're over here on the right. So NM, non-metals. Metals are here on the left. And what we call the staircase in the middle Those are where what we would call the metalloids or semi-metals. And I'll talk really about what semi-metals mean in a second. So let me open up your periodic table and explain. And there are two exceptions I want you guys to know. Somebody has their mic on. Is there a question? No? Okay. So two exceptions before I move on to the next slide. Metalloids or semi-metals is the same thing. They border the staircase or stair-step line. Aluminum is not considered a semi-metal. Aluminum metal is a pure metal. Aluminum foil, you might have aluminum pots and pans in your kitchen. You might have aluminum rims on your car. Maybe not. Aluminum's pretty fragile, but aluminum is a metal. So it doesn't belong with the metalloids or semi-metals. The other one that doesn't belong is hydrogen. Hydrogen is obviously not a metal. Hydrogen is a gas. It has one proton. I mean, literally, when you guys think of metals, I want you to think of something metallic, like jewelry, a silver ring, a gold ring, stainless steel. That's what metals are. So just let me open up something for you. Good old data book here. Uh-oh, I don't know. Hold on, I gotta close this. Sorry. My old data book had drawings all over it from the last class. So like, look at your data booklet here. I'm just gonna share it with you now. Like, I really want you to think about how easy this is. If you get into a test or you're doing a quiz or your final exam and you can't remember which is which, what I mean is you're having a brain meltdown and you're writing your test and you can't remember if metals are on the left or right. Think about the elements you're looking at. Okay, nickel, iron, gold, silver. What's another one? Lead, right? Copper. When you hear the words iron, nickel, copper, silver, your brain should instantly say metal. Oops, sorry. When you hear the word nitrogen, oxygen, chlorine, these are not metals. They're not shiny, they're not solids, they're not gray metallic objects. They're just gases. I mean, we breathe in oxygen to live. We breathe in a lot of nitrogen in the atmosphere. These are non-metals. Oops. And this is the staircase. So you know what I mean by staircase? Like steps, right? When you're in building 5 and you take the steps, hopefully you take the steps instead of the elevator sometimes for health. And plus, with Corona or COVID, I wouldn't get in an elevator with too many people. So these are your steps. They look exactly like steps. And anything basically touching these steps, you can call a semi-metal, except aluminum. Don't count aluminum. Aluminum is a metal. Think about aluminum foil in your kitchen. It's shiny, it's silver looking or gray. It's definitely a metal. All right, this is pretty easy, I hope. Let me get back to my PowerPoint and share again. And we're almost done for today, actually. One thing, I'm going to go a little quick through this because it is on this slide. Well, not that I'm going to go quick, but really, one of the big things you guys will need to know for chapter 3 and 4 is metals tend to form positively charged ions. And remember what we call those? Cations. Non-metals like to form negatively charged ions, so anions. All right, and basically there's a little what we would call a trend here. As you go down and left across the periodic table, things become more metallic. And all I'm saying is, if you draw the periodic table, okay, metals are this way. Non-metals, metals, okay? Non-metals, metals. We will come back to this in another chapter. Like, there is a reason, and it's a really easy reason once I get to it, to why do metals lose electrons and why do non-metals gain electrons. There is a reason, and we're going to learn about that actually in this unit. Oh, sorry about that. Guys, in my last class, I had somebody knock on the door twice. I had the fire alarm go off, but my dog didn't say anything. Now my dog's going crazy. All right, shush. Be good. Okay, so what I want you to think about is, looking at that periodic table, I want you to notice something. In the top left of the periodic table, this would be top right, sorry. You'll notice you see a lot of gases, and in the bottom left, you'll notice you see a lot of solids. Now, you do not have to memorize that. If you look at your periodic table, oh, somebody just said something in the chat. I'll read that in a second. If you look at this periodic table I have here, gases are pink, or whatever that color is. These guys over here are about as non-metal as you can get. They're all gases. But notice as I go this way, they're all solids. So on this periodic table, all the solids are white, all the gases are pink. And isn't it interesting? Sorry, I'm going to clean off my screen here. I just had to clean it up. Just give me 1 second. I'll bring it back up. I don't know how to clear my screen in Adobe. This is brand new that I can actually write in Adobe. So sorry about that. If you look, so again, we have our gases here. Okay. Hydrogen is a non-metal as well because it's a gas. All of these are metals and they're solid. But look, there's only 2 blue things on that whole periodic table. Only 2 of these elements exist as liquids: bromine and mercury. They're the only 2 that exist as liquids. Very cool, both of these chemicals are extremely dangerous. So guys, if I ever ask you if an element is a solid, if it's white, it's a solid. If I ask you if it's a gas, well, if it's pink or orange or whatever this color is, it's a gas. And that's basically it. The synthetic stuff we don't have to worry about for now. Synthetic just means it was created in a lab. It's not technically found on Earth naturally. It's been made by humans. Okay, all right, so 1, 2, 3, 4 more slides and we are done. All right, this is definitely something you want to know. This would be wink, wink, wink. I'm winking right now at the camera. This would be a fantastic multiple choice type question where I might ask you, which is a property of a metal or which is a property of a non-metal. So let's read 4 different properties. Metals tend to be shiny. The word luster means shiny. And when you hear the word shiny, think of new jewelry, you know, a nice ring, a nice necklace, or you get your car cleaned very well and it shines in the sunlight. Non-metals don't really do that. Metals are shiny, non-metals aren't shiny. Most metals tend to be silver or gray. Non-metals can be any color. Chlorine is green, bromine is red, oxygen has no color. Okay, so talking about their shininess or their colors, metals are shiny and usually gray or silver. Non-metals are shiny and they can have lots of colors. Now, this one can be a little bit more challenging. You need to know what these words mean. Solids are malleable, which means they can bend, and ductile, which means they can stretch. Solids or non-metal solids are usually brittle, which means they break. And I have break meaning like shatter or smash. I want you to think of, you know, this is maybe not the happiest of examples, but I want you to think of a car accident, a vehicle accident in Doha or in Qatar. When you're driving by an accident, or maybe you have been in an accident, and you look at your vehicle, the metal on your vehicle will be bent or stretched out of shape. There will be dents in your car, you know, big dents. But when a car or a vehicle accident happens, the car just doesn't smash or crack into a million pieces. But a non-metal, like glass, guys, is a solid non-metal compound. What happens with glass in an accident? It breaks into a million pieces. Okay, it shatters. So metals, you can bend a metal, you can stretch a metal, but non-metals, if they're solid, they don't bend, they just break. They'll crack in half. Okay, the only other one you need to know on this table is this one. You can ignore this one for now. I don't think we'll worry about this one at all, but this one on the bottom is very important for chapter 5, or sorry, chapter 3 and 4. I don't know why my brain said 5. Metals like to form cations. Non-metals like to form negative compounds. Anions and oxyanions we will talk about later. So this last part we're going to talk about in our naming chapter, Unit 3. I'm very, very excited for Unit 3, I have to say. I think when we get to Unit 3, you guys might like this stuff a little bit more. All right. The only other chemical, because I've been talking about metals and I've been talking about non-metals, but what about the other stuff? What about the metalloids, right? The semi-metals. Well, the easiest definition of a semi-metal is think of what the word semi means. Semi means half, you know? So a semi-metal is something that's kind of like a metal and kind of like a non-metal. And an example of this is silicon. It has characteristics of metals and also characteristics of non-metals. So metal, we know, conducts electricity very well. I got a message in the chat, I'll have a look at that. Silicon is a chemical right on the staircase. And this chemical is shiny like a metal, and it can be bent like a metal. Or sorry, not bent like a metal, it's shiny like a metal, but it's brittle like a non-metal, and it's a fairly poor conductor of electricity or heat. And there's something really, really important about that. Yeah, oh, that's a really good example, Mohammed. And Iman, I never got back to your comment. I'm sorry about that. I'm going to read Iman's comment in a minute because she's very right. But Mohammed, yeah, think of a final or a semifinal. If you're into sports, football, basketball. I like the more Western. Like I love hockey or American football. A semifinal. It's not quite the final match, but you're really close. The teams have made it so far. You're almost at the final, but you're not. And Iman mentioned earlier, and I really apologize for not reading this. Non-metals have extra electrons, and metals need electrons. You are exactly right. But Aman, I'm going to come back to that later. That's a little advanced for us now, but I will come back to that. And Franz in the chat, I missed your comment too. I will check store 974. I'll put that into my phone now and see if they have a good microphone. The only store I haven't been to for a microphone that I'd like to try is Gerrare Bookstore. But I went to like Fnac and a few Virgins and a couple other computer places, and they didn't have any. So I might check Gerrare or 5. What was it? 974. Anyways, 974. Okay, so I'm going to end this class with a fun fact, and then you guys are free to go. Well, basically, I'll end this with a fun fact, and then this question I'll leave open for you guys to think about for tomorrow's class. So, fun fact for you all. Silicon, which is a semi-metal or a metalloid, semi-metal, metalloid, same. The reason I like semi-metal better is because I spelled that wrong. It tells you exactly what it is. It's like a semi-final. It's not quite a metal. Silicon is a semi-metal. And the reason it's a semi-metal is, well, it's on the staircase, but what happens with silicon is it has metallic properties. It's solid, it's a silver shape, but it's a poor conductor. And I want you to think about every piece of electronic equipment you have in your life, your cell phone, your laptop, your iPad, your Android, your TV, your microwave, your car, every electronic component that you can think of probably contains computer components, right? If your device has some sort of computing power from a calculator to a flat screen TV, it has semiconductors. Now think about your car, your cell phone, your calculator, your TV. They're all wrapped in plastic. So why doesn't the plastic melt? When you put electricity through, no problem, Hamza. We're almost done now though, but you can watch the class on YouTube later. Sorry guys. When you put electricity through a metal, it gets hot. Think about like wires, or even when you heat up like a metal pan on the top of your stove, they get hot. Why doesn't your calculator melt in your pocket, or your cell phone explode in your pocket? And most good cell phones don't explode these days. They are made of semiconductors. So they can transmit a little electricity to help power your calculator or your cell phone. We need electric current to turn a phone on, but they won't get so hot that it will melt. Without silicon, we wouldn't have cell phones. We wouldn't have anything technological that I can think of, anything that is computer based. So the fun fact I'm going to end you guys on is, have any of you ever heard of the term Silicon Valley? It's in America. Sorry, just had to grab something. I'm going to open up the chat here. Silicon Valley. No problem, Hamza, if you're late. You can always watch the video later. Aman mentions cooking with iron products. Iron conducts heat so well, or you'd probably cook with stainless steel or cast iron. Amazing conductors, they get so hot. And Kevin and Warda are mentioning they have heard of Silicon Valley. Silicon Valley is where Google, Apple, Facebook are located. And these are computer-based places. And they're named after the element silicon. Without silicon, we wouldn't have computer chips. There'd be no Google, there'd be no Facebook, there'd be no, what's the other one that's there? Apple. I guess Apple's one of the most famous in Silicon Valley. So yeah, if you've ever heard the term Silicon Valley, it comes from the element. And the element is so special because it kind of conducts electricity, but it doesn't get too hot. So we can turn on a computer and a cell phone and it won't melt your pocket. Okay, so tomorrow, guys, we will do this example. And basically, while you're waiting for me to start the class, I'll put this slide up. And what I want you to do tomorrow, and this is wink, 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 a good test question. Look at these substances and tell me if they are metals, nonmetals, or semi-metals or metalloids. Okay? So I am going to stop the recording now. Remember, on Tuesdays, I end a little early because of my labs. But if you guys have any questions, you can let me know. So other than that, have a great day.